Okay, let's continue with arithmetic progression annuities. So far, the annuities we learned, they are level payment annuities. For example, if you take annuity immediate, the payment look like this. You have some fixed payment amount, the constant payment amount over the term of the annuity. They are level payment. So now we want to discuss what happens if payment amount increase or decrease according to arithmetic progression. So what is arithmetic progression? Under arithmetic progression, you can say nth term is given by a1 plus n1 n minus 1 time d. Okay. So for example, you can have this kind of series. This is arithmetic progression series. Or you can have something like this. This one is arithmetic decreasing a sequence. So we are talking about what happened if payments either increase or decrease according to this kind of arithmetic progression formula. So the first one would be what happened if you have payment 1 unit payment time 1, and then it's increased by 1 unit. So this is called the unit increase in annuity. You can have the same thing, but starting from n and then decrease all the way up to 1. That's called unit decreasing annuity. And then again, you can divide it to two types, due and immediate. And the immediate one start the first payment at the beginning, at the end of the time period, and the due one start the beginning of the time period. So we want to get the formula for this. So what we are going to do, we are really going to first derive a formula for generalized, the general arithmetic progression sequence. So then we would get all these special setup. So let's think about the possible ones, like the most general one. You can have time 0 here. This is for immediate. Okay. So I'm developing a formula for arithmetic progression annuities, but with the time first payment at the end of the first time period. Okay, so this would be look like this. P, this one is P plus Q. Then here N, that would be P plus N minus 1 time Q. So I want to this. So in here, it's very general. So P can be anything. If I want unit, it's going to be 1. Then the Q is going to be 1. Okay, um, but this formula, this setup, we can apply for any P and Q. So I'm going to get a very general formula. So in order to get the present value, I can discount it to time 0. So you can say it's P time V. And the next term is P plus Q, V square, all the way up to P plus N minus 1 Q, V N. So now what I can do, I can multiply, this is equation 1. I can multiply equation 1 by 1 plus I. So let me multiply equation 1 by 1 plus I. I time equation 1, that would result 1 plus I time PV in the left hand side, and the right hand side we will get something like this. P plus QV. Why is that? Because 1 plus I time V is 1, okay? Remember that relationship. So, V n minus 1. So I can subtract 2 minus 1 and see what do I get. So that would result I time PV. So you can see that right away. You will have equation like P then so let me maybe expand this. P plus Next one is P plus Q minus PV. Next term would be P plus Q P plus 2Q. So if I go to the next term here, it would be P plus 2Q V square. So I'm taking the, so if I do that way, so I would get P plus 2Q minus P minus Q times V square, and all the way up to the last one. Last one would be minus sine P plus n minus 1 Q V n. Okay, so I have here IPV. So you can see the P cancel out. So I get P here. Then I have the Q term. If you add all of those Q term, you would get V all the way up to Vn minus 1. And then I have this other one, P plus n time Q minus Q Vn. Okay. So I can expand this. I can bring this Q term, because when you multiply by minus sign, it's become plus. No? So I can put it into this the next parentheses, and it's become Vn. Then I can get this. So this become negative PVN plus minus NQVN. Okay. Remember that the last Q went to inside here. Okay. So I'm talking about this P and this NQ term. Okay, those are in here. In here, negative, negative, plus, and then I took the Q as common factor and put the Vn in here. Okay. Okay, so now let's bring these P terms together. So I would get 1 minus Vn there. Then plus Q time. Let's put these together. Then let's put this one here. So now right away you can see this is so let me yeah, so right away you can see this is basically percent value of annuity immediate. Okay, so I can write one more line. Plus Q, this is AN minus NVN. So now I can divide both sides by I. Now this is actually, we have a full name for that. That is annuity immediates. So now if I want unity increase, I can set this to be 1. Okay, so if unity increase P is 1, Q is 1, unit increase. Then the formula for present value is this nice one, IAN. So it's going to be AN because P is 1 and Q is also 1. So I have here this. What you can do, you can multiply, you can take the common factor, because here you can see that's a nice formula. So let's try I time AN plus AN minus I, which give you 1 plus I time AN minus NVN over I. And this is actually annuity immediate DU formula. You can check it. Okay. So that's how you get that nice formula. So So just check 1 plus I time AN. Is it going to be A double dot? You know the both formula, okay, so you can check it. The same thing for decreasing. In that case, you set the Q to be -1. Okay, so for in this case, in this formula, you would set P equal 1 and Q equal -1. Okay, so then you can get this nice. It's decreasing there. P equal N, sorry, P equal N. P equal N and Q equal -1. Okay, so when you have this kind of arithmetic progression, annuity immediate, so we have 1 plus formula. Percent value is going to be P time AN plus Q time AN minus N time VN over I. Okay, so and you need to memorize that formula. P is first the starting value, and the Q is how the values are increment. It can be increasing or decreasing. If it is increment, it's going to be positive Q value. If it's decrease, its Q is going to be negative Q value. Okay. The next one would be what happen if payments in annuity immediate. Okay, so let me draw the timeline, and we derive a very general formula. So here is 0, 1. This one is P, P plus Q, and here is N minus 1. And here is time. So percent value, if you write the first line, it's going to be what? P plus QV, because you have to discount it times now 0, and all the way up to P plus N minus 1 Q V N minus 1. So you can try the same approach you implement, multiplying by 1 plus I, and see whether you can get a formula. So let's see. So this is equation 1, and if I multiply 1 by 1 plus I would get 1 plus I time PV. So it is going to be P plus PV actually. PV. Oh no, 1 plus I time 2. So now see, so I'm not going to do it, but see whether using these two equations, whether you can get the formula given in here. Okay. So the formula is this one. Okay. So these two formula you need to remember and memorize. You can see right away very similarities. AN, QAN minus NV, and then here you have A double that. Okay, so DU you have this one, and D. Immediate, you have immediate and I. Otherwise, it's very similar. Okay. For future value, always you can use this nice formula, future value equal percent value times 1 plus I to the n. Okay, so if you remember the percent value formula for general arithmetic progression annuities, then the future value derivation is not that hard. Okay, let's do some problems. So here it says Susan receives an annuity for her 18th birthday. The annuity pays 2,000 on her 19th birthday, and then has an annual payment on each of her birthday through her 35th birthday. Each year, the payment is increased by 500. Find the value of annuity on Susan's 18th birthday, assuming annual rate of 4.2. So let's draw the timeline and see what this means. So this is 18, 2,000 on her 19th birthday. Annual payment on each of birthday through her 35th birthday. Each year, the payment is increased by 500. And then 35th. It's going to be what? So it's going to be 35 minus 18 minus 1 times 500. So for example, if it is 220, you multiply 500 by 1. So 20 minus 18 is 2 minus 1. So then 35 minus 18 minus 1. Okay. So the formula would be what? It's this arithmetic increase in annuity. So P is 2000, Q is 500, and we want to know the percent. We want to know the percent value. Okay, on 18th birthday. So here, so we want to know the percent value. Okay, so we can write the formula. This annuity immediate. This is the formula. Next thing you need to substitute the value. So P is 2000. And what's the N? N is going to be 35 minus 18, which is, let's see, SOA calculator. It is 17. And the rate is 4.2. It's effective. Remember that. The Q is 500. Is 17 minus 17 V17 over I. And remember, V is 1 over 1.042 and I is 0.042. Okay. So you have all the things you need to calculate this percent value. So one thing you can easily do, you use your calculator to get A17. So N is 17. I over Y is 4.2. Compounding per year, payment per year is 1. And then percent value is what you want. This symbol means unit payment, so it's 1, and then future value is 0. So if I use my calculator, let me reset this. So let's calculate the value of that annuity symbol. So N is 17, 4.2 for IOY is going to be 1. Oh, this one should be 1. Just make sure we let me enter 4.2 for then the payment is 1, future value is 0, and I'm computing percent value. 17 point. Did I enter that? Okay, so percent value. So compute percent value. It's going to be negative 11.9. So A17 is 11.98. A negative sign actually symbol of whether payments are coming to us or whether payments are going from us. So we use just the absolute value, which is going to be 11.9. Okay, so now, so I can come here and I can substitute those values. So P is 2000, A7 is 11.98, Q is 500, A17 is 11.98, minus 17 times 1.042 to the negative 17 over 0.042. Okay, that's how you do that kind of problem. In this problem, at the end of each year, Mr. Dunn deposits $6,000 into an investment fund. The fund pays out interest each year at an annual effective rate of 6%. Mr. Dunn is only able to reinvest his interest at an annual effective interest rate of 4%. Okay, so let's see how you do this kind of problem. So you are at the end of each year, Mr. Dunn deposits 6,000 into investment fund. Okay, so how many years? For 20 years. Then the fund pays out interest each year at an annual rate of 6%. Okay, so rate I should use here 6%. It's effective rate. Then Dunn only able reinvest this interest at an annual effective rate of 4%. So what that person going to do, the reinvest interest. Okay, so what's the interest amount for 6,000? So you can see the interest is going to be the first one. So you invest 6,000 at the end of the first time period. So you're going to get the interest. So this is interest. Reinvest. So 0, 1, 2, 6,000 times 6%, which is going to be 360. Then the next time period, it would be you have 12,000 and you have to calculate the rate under 6%. Because you already you take out your interest, so you don't have anything else. So 12,000 under 6%, that's going to be 720. The next time you have 18,000 in your account, and then you have to calculate the interest for that one. It's going to be 1,080. Now this account going to earn interest for 4%. Again, effective. So we do this until 20. What is the account value of at the time of the last deposit? So when you come to here, what is the accumulated value? Okay, we have to consider both. Okay, so the first thing, what's the account value of the first account? The answer would be easy because since you are withdrawing all the interest, there's nothing left except the 6,000 you are depositing. So this would be 6,000 time how many deposit? That's going to be 20, no? Yeah, so it's going to be 120,000. This one is the tricky one because in here the interest payments are increasing, and also it's going to earn interest of 4%. Okay, so you're depositing in a manner which come under arithmetic progression, and then also that's going to earn 4% interest. So for this one, we had to use the arithmetic progression annuity formula. So I have P, you can see the first one is 360. The difference is going to be always 360. You can check this. It's going to be 360. So increment is 360. Then the N, you can see only it's going to be, if you take the difference between these two, it's going to be 19. So that's going to be 19. And then you can think it's more like annuity immediate, and then you have to find the future value at time point here. Okay. So this is immediate. And the rate is 4%. Compounding is 1. Percent value, we don't need that. So we set 0. Future value is what we want. And the, oh, wait, wait, let me write the first formula. So this would be V time AN plus Q time AN minus NV N over I. So I'm calculating here actually AN. Otherwise, this formula you cannot calculate directly from calculator. You have to use your formula. So let me write this formula first. So huge percent value of money of interest reinvested. Okay, so first we get present value, then we get the future value. Okay, so we need future value here. But what we are going to do, we are going to find the present value here, and then we use that formula to get the future value. Okay, so so P is 360, A19 plus Q is 360, A19, N is 19, V is we had to use 4%, okay, because for that account um, um, and only 4%. Okay, so V is actually 1.04 to the power negative 1. Okay, but let me write V 19 here I. Okay. So for this one, V is 1.04 to the negative 1 and I is 0.04. Now let's calculate a 19. Now that's what I was doing here. So so rate is 4%, compounding is 1%, value is 0, future value, present value is what we want. As future value is 0 and the payment is 1. Okay, let's use our calculator. So let me second. Okay, so let me put the 4 for IOY. Payment is 1, compounding is 1. Then the N is 19. 1 is for payment, 0 for future value. We are computing percent. So it's 13.13. So A19, 13.13. Yeah. Okay, so now we can substitute that value here. So when you solve this, you get percent value. Okay, so let's solve it and see what's the percent value. 13.13 minus 19 times 1.04 to the power negative 19 divided by 0.04 60 plus 60 times. This one is going to be 41,732.94549. Okay, so you want to calculate the future value? Future value is present value time 1 plus I to the, so you calculate the present value on time 1. Okay, so you are calculating now future value on time 20. So the difference between that is 19. Okay, so 0.04 to the 19. And you would get 87,925.02181. And you can add that to this 120,000 to get the total equivalent value. So here is another question. Alfonso had an annuity that will pay 4,000 on October 30, 2010 and has annual payment through October 30, 2024. The payment increased by 800 each year. As soon as Alfonso receives payment, he will deposit it in a saving account with 4% annual rate. Will not make any withdrawal. What will? So it is exactly the same like the previous question. So I would advise you to try this question and then ask from me whether you are right or wrong. Because this is exactly look like the previous question. So let me draw the timeline just to give you some idea. So here you are in time 0. We'll pay 4,000 on October 30, 2010. Then has annual payment to October 30. So October, so this is October 30, 2010. Then the next one, October 30, 2011, is annual payment and increased by 800. And the last one would be October 30, 2024. Okay, so how many years? 24 minus 10, that would give you 14 minus 113. So 13 times 8. Oh no, 14. This is 14. 14 times 8. This one come under due, okay, because payment started at the beginning of the time period. So now every time when you get that money, what you're going to do, you're going to deposit it into a saving account 4%. Okay. So the rate is actually 4%. So what would be the so basically now you had to use P a double dot N. First find the percent value here, then get the future value on here. Oh, so it's asking October 30th. So this is October 30th. So on this day, so yeah, so future value on here. So you can use the percent value of this equation, PAN plus Q, AN minus NVN over D. And then future value equal percent value times 1 plus I to the N, which is going to be 15. Okay, so try to do the question. I gave you some hints, so it should be easy. Okay, so what happens if you have perpetuity, where the payments increase according to arithmetic progression? So right away you can see we can use the formula we derived and then send n to infinity and get the answer. So when n goes to infinity, you can see so in here what's this formula? This is p time 1 minus vn over I. When n goes to infinity, this one becomes 0. So from here you get p over I. That's the stuff. Then in here, if I expand this, when n goes to infinity, you can prove this one going to be 0, and then this one also going to be 0. So you end up with q 1 over I, then divide by I, which is q over I squared. So this is the formula. The same thing for the same kind of formula for the next one. Only difference is here you have ID. Okay. So Rafael purchased and perpetuity immediate. The perpetuity pays 1,000 at the end of each of the first 7 years, and then has payment that increased by 180 each year. So the payment at time 11 is 1,000, and the payment at time 12 is 1,080. The purchase price was determined using 5% on effective rate. Find Rafael purchase. So let's draw the timeline and see how it's look like. It's immediate. Okay, so the first one is at the first end of first one. Each of the first 11 years. So this is the first year, second year, third year, and then the next 11. This is the end of 11th year. And the starting 12th year, the payment increased by 180. So let's go to perpetuity. Okay, so we want to find the percent value. You can see that this 1,000 is kind of like a fixed. Okay. So you can get the percent value of that 1,000 first. So percent value of 1,000 perpetuity. That's a constant. That's a level payment. So we know how to get the percent value. What is that? P over I. We have the annuity median. The usual formula is percent value is what? Payment time AN, which is payment time 1 minus Vn over I. And n goes to infinity, you end up with just payment over I. Okay. So that's why it's P over I. So in this case, payment is 1,000. and rate is 5%. Okay. Now the next set is 180, 360. That's the arithmetic progression one. So let's try to get the present value on that. So I want to redraw that timeline. Here I have 10, 11, 12. I got 180. Okay. Remember we separate those payments. Okay. And 13, 360, and it's called all the way to be to the perpetuity. So if I'm standing here, for me, the present value would be 1. So present value would be P over I plus, because it's a perpetuity immediate, but I'm under the arithmetic progression, so Q over I square. So that's going to be 360 over 0.05 plus the increment is again 180. Okay. No, so P is 180. Q also 180. Increment also 180. 180 over 0.05 square. That's give you the present value. But I don't need the present value at time 11. I need at time 0. So I have discount by 11. Okay, so at time 0, the present value would be 1 plus I to negative 11 and be 2. Okay. So then you have to add these two. So let's get the present value for that 1,000 cash flow. So so this would be what? It's going to be 20,000. Then in here it's going to be here if you simplify this 180 divided by 0.05 plus 180 divided by 0.05 square, you would get 75,600. And then you have discounted by 1 plus I to the 11. So 1.05 negative 11 times 5,600. Then you add it. So this one will give you 44,201.75425. And then you add that with this one. Okay. Plus 20,000. So the final answer would be 64,201.75. Because you have to add the first and second. Okay, so the next lesson we are going to discuss geometric progression. So let's meet in that lesson again.